lecture 77. Lecture 77. So, we were discussing about series connections. Similarly, if you can connect this one in parallel also. For example, if you have a two port network like this, this is suppose V 1, this is I 1 and this is suppose V 2 and this is suppose I 2. These are two port networks. Okay. Now, you have another network which are having things like this. This is plus minus say V 1 dashed, this is plus minus V 2 dashed and this is I 1 dashed and this is I 2 dashed. This is the thing. Okay. These two networks, when we say we will connect them in parallel, we mean that of course, two sources can be connected in parallel. For example, these input ports should be connected in parallel, plus with plus, minus with minus, and that is connect input ports in parallel and output ports in parallel. Connection so that means I take a piece of wire, I connect this point with this and I connect this point with this, and this obviously I can connect these two in parallel. If I connect it in parallel, V 1 dashed must be equal to V 1, nothing doing. Similarly, the output ports I will connect the terminals in parallel, that is this plus with plus and this minus with minus, and this are the overall output terminals, this is input terminals. Now, in this case, as it will turn out to be, if you express this networks 1 and network 2 in terms of admittance parameters, then the equivalent parameter values will be sum of the admittances. That is the whole idea. So, first of all, I write down the equations as in terms of admittance parameters, that is suppose I 1 for this two port network I 1 is equal to y 1 1 V 1 plus y 1 2 V 2 and I 2 is equal to y 2 1 V 1 plus y 2 2 into V 2. These are the basic equation for network 1. This is the thing. For network 2, this time I will straight away write down, that is I 1 dashed, in this case I 1 dashed will be equal to y 1 1 dashed for this network, which whose parameters I am marking with prime numbers. So, y 1 1 dashed into V 1 dashed, but V 1 dashed is equal to V 1. So, I am straight away writing this as V 1 instead of skipping a step, plus y 1 2 dashed into V 2 dashed, but V 2 dashed and V 2 are same. So, I am writing it as V 2 like this. Similarly, I 2 dashed I am sorry, here y dashed I have written I 2, this is I 2 dashed. Similarly, for this I 2 dashed, for this concentrate on this, it will be equal to y 2 1 into V 1 dashed, but V 1 dashed and V 1 are same. So, mind you V 1 is equal to V 1 dashed. Similarly, V 2 is equal to V 2 dashed. Therefore, I 2 dashed is equal to y 2 1 dashed into V 1 plus y 2 2 into V 2 prime. Okay. Now, what you do if you call 1, 2, 3, 4, then add 1 plus 3, add 1 plus 3. It will give you I 1 plus I 1 dashed, that is this equation, and this equation I am adding 1 plus 3. So, I 1 plus I 1 dashed is equal to, it will be equal to y 1 1 plus y 1 1 dashed into V 1 plus y 1 2 plus y 1 2 dashed into V 2, and similarly add 2 plus 4, equation 2 and 4 you add. If you add, you will get I 2 plus I 2 dashed is equal to y 2 1 plus y 2 1 dashed V 1 plus y 2 2 plus y 2 2 dashed V 2. So, this is the thing. Therefore, this whole network can be considered to be an equivalently you can think of this network to be a single 2 port network whose input voltage is either of these voltages V 1 plus minus, but in input currents of this is I 1 plus I 1 dashed is what? Is this input current, is not I 1 plus I 1 dashed. Similarly, this side it will be equal to V 2, and as you can see this current is I 2 plus I 2 dashed. I 2 is going, I 2 dashed is going here. So, I 2 plus I 2 dashed. Therefore, so output port current is this one I 2 plus I 2 dashed, and the equivalent the admittance parameter of this network will simply be the sum of the y parameters. Therefore, if several 2 port networks are connected in parallel, you simply go on adding the parameter values of each one them. Therefore, equivalent y matrix will be equal to obviously y 1 1, y 1 2, y 2 1, y 2 2 plus y 1 1 dashed, y 1 2 dashed, y 2 1 dashed, and y 2 2 dashed. That is what we have seen. Now, there is another interesting connection which is called cascade connection. Two 2 port networks in cascade. In cascade means the output of one port is the input, the output whatever you get from the first port is connected. Suppose this is network 1, it is plus minus V 1, this is I 1, you connect it and you have another network N 2 whose input you connect to this port. Got the point? This is plus minus, this is V 2 and say so B 1 it will have its terminal and you consider this to be your V 1 dashed and it will be shown here if these two networks are connected in cascade, the representing each one of these two port network in terms of its ABCD parameters is beneficial. Then the product I think it will come of these two matrices will give you the overall two port network thing. For example, let us try to do that. What let us show that this is I 1 for two ABCD parameter representation. I will do represent each two port network in terms of ABCD parameters. That is network 1 is suppose its ABCD parameters are A 1, B 1, C 1, D 1. Similarly, for this network ABCD parameters are A 2, B 2, C 2, D 2, like that we will represent. Now, so far as the first network is concerned, we know that for ABCD parameters we have V 1 is equal to V 1 input parameters V 1 I 1, and since I will be writing ABCD representation. So, I 2 direction I have reversed, it is like this as we have been doing all the time. So, V 1 is equal to A 1 into V 2 plus B 1 into I 2 for this network. This is V 2, this is I 2 and I 1 is equal to B 1 C 1 into V 2 plus D 1 into I 2. This will be the thing, clear. Now, for this second net, this is for N 1, this will be the thing. For the second network, this is the input current of the second network, which is suppose prime I 2, I 1 dashed is the input current and input voltage is V 1 dashed and output voltage I will write it as V 2 dashed and output current as I 2 dashed. This is what I will do. Therefore, for this network the relationship will be V 1 dashed is equal to A 2 into V 2 dashed plus B 2 into I 2 dashed. That is what I will do for this. and in the second equation, that is I 1 dashed is equal to what? C 2 V 2 dashed plus D 2 I 2 dashed. That is what I will do, is not. But you see that V 1 dashed and V 2 are same, this V 2. So, this is nothing but V 2 itself. Similarly, I 1 dashed is nothing but I 2 itself. So, here first I write it is V 1 I 1 is equal to A 1 B 1 C 1 D 1, and here we write V 2 I 2. This is the thing, and here we write, we also get this as V 2 I 2, its input quantities V 1 dashed is equal to V 2 because of this parallel connection, and V 2 I 2 is equal to A 2 B 2 C 2 D 2 and V 2 dashed and I 2 dashed. This way I will write it, you know, this is the thing. So, if you want to get the overall structure, suppose I want to replace this whole thing by a simple 2-port network with this thing, that is, this is I 2 dashed, this is plus minus V 2 dashed, and here you have applied V 1 and this is current. This is the equivalent. That is, I can represent these two cascaded 2-port networks as a single 2-port network equivalent. Now, what you can see from this equation V 1 I 1 or this equal to A 1 B 1 C 1 D 1 is this thing into V 2 I 2, but this column vector V 2 I 2 is nothing but this. So, substitute this column vector in terms of the product of A 2 B 2 C 2 D 2 and V 2 dash I 2 dash. So, this can be written as A 2 B 2 C 2 and D 2, and this will be V 2 dashed and I 2 dashed. So, the overall the ABCD parameters of this ABCD parameters of this equivalent 2-port network will be product of these two matrices, because this is product, is not. So, this is equivalent to, it will be also a 2 by 2 matrix, whatever it will be, that is A 1 A 2 plus B 1 C 2 etc. So, this will be the A equivalent, some whatever you get, you say B equivalent, C equivalent and D equivalent. So, this equivalent ABCD matrix will be just product of these two A 1 B 1 C 1 D 1 into A 2 B 2 and C 2 D 2, that all. So, very easy. Therefore, if several 2-port networks are cascade connection means what then? the input voltage of this second network is the output voltage of the first, and so on. You can connect several in cascade. So, the product of the ABCD parameters will give you the equivalent representation ABCD parameters of the networks. That is what I want to tell you. Is that clear? Therefore, see, it therefore depends if it is transmission line parameters and there will be several networks connected one after another, that is in cascade. It is better you deal with ABCD parameters. Equivalent ABCD parameters will be simply multiplication of these 2 by 2 matrices. As many stages are there, so many multiplication you have to do. Similarly, if the networks are in series connected mode, and by series connection I mean the way it was connected, input ports are series connected, output ports are series connected. In that case, if each one of these ports are represented in Z parameters, equivalent Z parameters can be easily calculated. It does not mean that this cannot be represented in ABCD parameters, it can be, but then the equivalent Z will come in a complex way. And we already know that if you have represented the networks in any form, either H or Y or Z parameters terms, then you can find out the parameter values for other representation. We have to do a little bit of work, algebra there, that is all. So, this is how things will go around. Anyway, so these are the 3 connections I told you, and you go through it, and if you find any further conditions should be put, you think about that. But I have assumed here the networks, each one of them are 2 ports, and I 1, I 1 dash etcetera are same, and so on. Now, I will tell you something about one 2 port. So far I was telling that 2 port networks may be anyway, let us start without much talking. Suppose how to represent a transformer, an ideal transformer as a 2 port network. We know what a transformer is. Suppose you have a ideal transformer here, these are the dot terminals of the transformer. Ideal transformer means no resistance, no leakage flux, etcetera. And if you apply a voltage here, you will get some induced voltage there. This is number of turns N 1, this is number of turns N 2, and if it delivers a current I 2 in this direction, 2 port network. So, I will I 2 and this is as I 1. Let us write the direction, it is my thing. If you write like this, then I will say we know that V 1 V 2 by V 1 is equal to N 2 by N 1, is not? This is one equation. And second equation is N 2 I 2, it is called MMF balance equation, is equal to N 1 into I 1. So, from this we say that this is the thing, and I 2 is equal to n 1 by n 2 into I 1. This way I can write. Similarly, I can write from this as V 2 is equal to n 2 by n 1 into V 1. Achha, so n 1 by n 2 is the ratio. Let n 1 by n 2 be a some number. Therefore, I will say V 2 is equal to a V 1. This is one equation from this. 1 by a. V 2 is equal to 1 by a. So, this is equal to V 1 by a, is it? If I define like this. So, n 2 by n 1 is 1 over a. So, this is one thing, and second thing is I 2 is equal to a I 1, isn't it? Or I can write it down, suppose V 1 is equal to a V 2, etc. I mean same equations I am, and it is I 2 by a. Now, the way I have assumed the direction of the current I 1 and I 2 like this, this one, this equation I am writing in matrix form V 1 I 1, that is input voltage and current in terms of the output voltage and current, and the direction of I 2 I have assumed like this. So, what will be this one? V 1 is equal to a V 2. So, a here it will be 0, no I 2, and I 1 is equal to I 2 by a. So, this is 0, this is 1 by a. So, it is also a 2-port network, but a 4-terminal 2-port network, not that these two are joined or what, even if it is joined you can. But what I am telling, this is a, this is a. What do you think these parameters? Is it Z, is it ABCD, is it H parameters? It is ABCD parameters, because I have assumed like I 2 like this, and input voltage and current is represented in terms of this. So, this one can be termed as an ABCD parameters of the network. So, this is nothing but ABCD parameter of the transformer. So, a transformer can be considered to be a what is called a 2-port network whose ABCD matrix is this. Can this be represented as an impedance matrix? To represent in terms of impedance matrix this transformer, what you have to do is this V 1 and V 2 you have to write in terms of I 1 and I 2, is not? This is what Z 1 1 I 1 plus Z 1 2 I 2 plus Z 2 1 I 1 plus Z 2 2 I 2. This is how you have to write it. Question is, can it be written like this? So, V 1 cannot be expressed in terms of I 1 I 2. Similarly, V 2 cannot be expressed in terms of that. That is, it looks like impedance matrix does not exist there. I will ask you to see carefully that whether ABCD parameters, if they are known, how they are related with Z parameters, and whether it is possible to obtain the impedance parameters or admittance. Similarly, admittance parameters, is it possible? That is I 1 I 2 is equal to y 1 1 V 1 plus y 1 2 V 2 and I 2 is equal to y 21 V 1 plus y 22 V 2. Can I write I 1 in terms of V? No. I 2 in terms of V? No, I cannot write. Can I write it in h parameters mode? For example, is it possible to write it V 1 I 2 you are writing. V 1 is equal to what? H 1 1 into I 1 plus H 1 2 into V 2, is not? And this is equal to H 2 1 I 1 plus H 2 2 into V 2. The question is V 1 is equal to A V 2. So, this one looks like there is no I 1 term. So, this one is A into V 2, is not? V 1 is equal to A V 2 and I 2 is equal to A into I 1, A into I 1. So, it looks like it can be written, is not? Therefore, h parameters exist. What will be h 1 1? 0. So, this same transformer as a 2 port network has a h parameter. It looks like what its value will be. H 1 1 that is 0 into I 1. So, 0, H 1 2 into V 2 that is A, is not? Then I 2 is equal to H 2 1 I 1 that is A, and of course, there is no contribution for V 2 0. So, you please behind all this representation, slight manipulations of the equation, in most of the cases you will be able to conclude several things, whether can I represent it in h parameters or y parameters or z parameters, things like that. We will continue with this idea and tell you about another 2 port network, which is an interesting network called gyrator in my next class. Thank you.